Now we're going to start looking at what the quantities in chemistry are going to be doing for us. We're going to start with a number concept today called the mole. So of course the question is, what's a mole? And we look at a mole and we say, okay, well, yeah, it's not one of these. They're cute and all, but it's something a little different. Let me start with asking you the question, what's a dozen? Um, Everybody knows what a dozen is, right? 12 of something, right? Well, a mole is a lot like that. It's really just a number. So instead of saying a dozen eggs, I could say I have a mole of eggs. No, that's an awful lot of eggs. The difference here is that instead of just being a number like 12, the number is an awful lot bigger. The number is 6.022 times 10 to the 23. That is a mind-boggling number and very difficult to wrap your brain around how that number is, how big that number really is. So what we're going to do in this note is just try and figure out, okay, let's kind of wrap our brains around how big this number is and what kind of calculations can we do with it. All right, so for starters, we're going to use this number for looking at particles, because really when we're looking at atoms and molecules, we're looking at particles that are so small you cannot see them with the naked eye. And the number of particles that you can actually see are quite significant. And this is where the mole really comes into its own. So that's the unit. We use Avogadro's constant, which is the number of moles or number of particles per mole, which is 6.022 times 10 to the 23. Avogadro is credited with having first discovered what this quantity is. We've since added quite a few more decimal places to it in terms of precision. However, we're just going to use this number here, 6.022 times 10 to the 23. You'll find that even some textbooks go to 6.02, just to simplify things a little bit more, but we'll stick with the 6.022 times 10 to the 23. All right, so what this means is if I have a mole of carbon atoms, then I have 6.022 times 10 to the 23 atoms of carbon. It's really straightforward. So how do we use calculations for this? The simple equation is that n is equal to n times Na. Lots of n's here, so let's differentiate them. The capital N is the number of particles, the lowercase n is the number of moles, and the n sub a is, of course, Avogadro's constant. All right, so this is where we need to bring in the idea of using our calculators properly, because the calculators are really required in order to do these kinds of calculations. There's very few people that can do this sort of thing, even with a pen and piece of paper. All right, let's do our first example. How many atoms are in 3.67 moles of chlorine? So this is chlorine atoms. You'll notice it's not Cl2. All right, using our formula, n equals n times Na. Substitute in the values. Lowercase n is the number of moles, 3.67. Avogadro's number, 6.022 times 10 to the 23. Multiply those together, and we get 2.210074 times 10 to the 24 atoms. Round to sig digs. In this question, the number given is 3 significant digits, so our answer has to be that as well. 2.21 times 10 to the 24. All right. Now, try this with your calculator.
All right, so here we have an array of calculators. It's important that we learn how to use these calculators for figuring out the questions that are related to scientific notation. It's amazing how I find that every year somebody doesn't know how to work their calculator. So we fall into these 4 different kinds of calculators, and really there's only 3 variations on this. The first one is where you actually have the button on there that has the times 10 to the whatever your exponent happens to be. So in case of Avogadro's number, we would punch in this case, let me turn that on. 6.022 times 10 to the 23. So that's how that number gets punched in there. A lot of people will try to go times 10 and then use the exponent button, which on this particular calculator is up here with shift log. And that in some cases will actually factor in an extra times 10 to that. And so you don't want to do that. The other variations of these calculators, for those of you who have the sharps, you actually use the exponent button. So you would go 6.022, and then you use this exponent button here, exp. And that puts in a times 10 to the, and leaves two little numbers there for you to fill in. And so the 23 then gets punched in like that. Okay, and so that means times 10. And you can see some of them will have the times 10 to the whatever the exponent happens to be. Some of them have the exponent button as exp as well, but down here at the bottom, like these Casios. And so same sort of thing, 6.022, and then you hit exp, and it puts a little e there instead of the times 10 to the 23. The e means the same thing. And so then we go 23, and now I can use that number. So for example, in our first question, we had this number now times 3.67, and then equals, and that gives you the value there. Let's do the same thing for this one, just so that we see what it looks like. So then times 3.67 equals, there you go, same number, times 3.67 equals, okay, same number. These Texas Instruments ones are a little bit weird. They have a double E button instead of the EXP. The double E is the same, essentially, operation that you need to do. And so this one would be 6.022 double E and then 23. It leaves out the times 10 to it, but you can see that the exponent is the raised value. Okay, and then I'm going to multiply that times 3.67 equals, and there's the same thing. Now you just got to be you watch that and understand on these TIs that it means times 10 to the 24. Okay, it's really important that you get that right. As I said, some people like to go 6.022 and then go times 10 and then use the hat, and so this one has the times 10 to the raised to the exponent and then punch in the exponent. And in some calculators that will actually create a problem in that your exponent ends up being bigger by a factor of 10, and that's going to mess you up. So make sure you know how to do this properly on whichever calculator you have.
One of the things that we have issues with is that people have a tendency to not use their calculators well. So inserting here, I'm going to put a little video on how to use your calculator. Pay attention to it. It's important. All right, second example. How many moles of, in 9.87 times 10 to the 25 atoms of hydrogen? So this is just the same equation, but we're going to rearrange it so that we figured out the lowercase n number of moles. So that's equal to n over Na. And so that works out to 9.87 times 10 to the 25 divided by Avogadro's number. And that is going to work out to 1.639 times 10 to the 2 moles. Again, rounding to 3 signigs, because the 9.87 is 3 significant digits. And that's 1.64 times 10 to the 2 moles. You could hear, in fact, some of your calculators, when they give you the answer, will probably give you 164. Or 163.9, whatever, however many decimal places. And that's not wrong, okay? Generally, when I have numbers in scientific notation, I will give my answer in scientific notation as well. That's not always necessary to do, especially with some of the smaller numbers like 164. That's fine, okay? All right, so here's today's homework. Go ahead and spend some time on that. When you're done that, you can move on to the next video and the next lesson.